So we have so far met 5 of these logical connectives, these symbols, and or not, implication and equivalence. And now we're going to introduce 2 more, and that's it. Those will be all of our logical symbols. These are usually called the connectives of propositional logic, and the ones we're going to introduce now are more complicated, and they definitely give people a lot more trouble, usually. And they are the quantifiers of so-called predicate logic. And we're sort of just mushing everything together and just calling all of our propositions or predicates, we're just calling them all propositions. But in some sense, there's a difference in the type of logic we're doing when we only focus on these 5 versus when we include these. So now that we are including these, variables are going to get involved. So if you remember, the way we described the grammar for these first 5 was to simply say that you combine propositions in some way with this symbol in the middle or on the left side, if it's this one, in order to get another proposition. These guys, however, are going to require a proposition and a variable rather than just propositions. So here's the grammar for this symbol. There it is without any anything filled in, and then so far that all of that is just sort of the structure of the symbol. And then you put a variable here and a proposition here. So variable goes here, any variable you want, so it doesn't have to be x, and any proposition can go here. And the result, all of this, will be a proposition. So that's the grammar. A variable must go here and a proposition must go here. Now, if you look in the notes, so there's an alternative notation that people sometimes use, which is to put a colon here, and that also works. That's fine. Some people use vertical bars, some people use colons. Usually in the lecture, I'll just do a vertical bar to save time, but in the notes, I sort of do both, like this, with this barbell symbol. And that's another one of those notations that's not standard, so you probably wouldn't want to carry it out of our particular course. In fact, you can just use a bar, and that's fine. But I sort of wanted to use a special symbol, and you'll see why. There's something special going on every time you see this symbol. Okay, so here's the way to read this. So you can read this symbol sort of like for all. And you can read the entire sentence like this. For all x, phi. So usually the proposition here will be something involving x. So it's not just going to be a random proposition, but something talking about the variable x. And in this construction, this part is called the quantifier. That's called the quantified variable. So often when we're talking about proofs, you'll probably hear me or see me typing that, hey, this variable is quantified, make sure you're treating it properly. This is what's meant. Quantified just means it's attached to a quantifier like this. And the area from here to here is called the scope of the quantifier. And it's very important that the scope is clear. So where the quantification of the statement here begins and where it ends. And that's why I'm insisting that it be enclosed in parentheses. So let's look at some examples. And once we're done, we'll visit this one. So this particular quantifier, the upside down A, the for all, this one is called the universal quantifier. And let me put in an example. Okay, here are a few examples. Now for this one, so notice that in each case I've filled in a proposition here. These are all propositions. And they don't have to involve x, but it would be weird for them not to. So here they all do talk about x in some way. And I mean, it doesn't have to be x, but what I mean is whatever is the quantified variable. In this case, it's always x. So the way I would read this is the first one says, for all x, x equals 3. The second one says, for all x, x loves y. The third one says, for all x, x is green. But that is actually a terrible way to read them. In reality, what these are trying to say has nothing to do with x. They're not really trying to talk about x itself. When a variable is quantified, that variable is not really part of what's being said. Instead, it's a placeholder for the purpose of the quantified statement. So for each of these, there should be a way to state what they're saying without mentioning the quantified variable. So let's think about for all x, x equals 3. Can I say that without mentioning x? If you want, you can pause the video and see if you can think of a way of saying that without mentioning x. So for all x, x equals 3. Think about how would you say that without saying the letter x in your sentence. So here's the answer. You would just say everything equals 3. That's all it's saying. It's a way to talk about everything all at once. Everything among what collection? Just everything. Just plain everything. Everything equals 3. In the sense that if you have a thing, if there's something that you can talk about in the language at all, then it equals 3 in order for this to be true. How about for all x, x loves y? That doesn't make sense. For all x, x loves y. So how would you read this without mentioning x? So since x is the quantified variable, this is not saying anything about x. Y is not quantified, however, so it must show up. So there should be a way to say this without mentioning x, but still mentioning y. Everything loves y. And for all x, x is green. Let me just skip to, it's just saying everything is green. Now notice that the variables that are not quantified really do show up no matter how you say things. So here the y is not quantified. So this really is a statement about y. It's saying everything loves y. Y specifically. Everything loves y specifically. So this is a statement about y, but it's not a statement about x. So x doesn't really need to refer to any particular thing here. It's not about x. It's just a way of saying everything. Now what if I change the quantified variable? What if I make this for all y, x loves y? Then this here, it's easy to make the fix. I would just put a y here. For all y, x loves y. But instead of saying everything loves y, this now says, see if you can guess. See if you can pause the video and guess. And here's the answer. It says x loves everything. So you have to mention x in order to say this statement, but it's not about y. It's about x specifically, but y doesn't matter. Y is just a placeholder in order to talk about how x loves everything. All right, let's talk about the existential quantifier. So instead of an upside down A, this one is a backwards E. And the grammar for it is the same as for the universal quantifier, except it's just a different symbol. So a variable goes here, and then you put this bar or barbell or whatever, and then you put a proposition here. So let's look at some examples. Okay, so the way to read this, so I didn't mention how to read it, is there exists x such that, and then whatever it says here. So actually, before looking at examples, let me just summarize the way to read these. So for universally quantified statements, for all x bar phi, you would read that as for all x, comma, phi. Notice the use of the comma here to make this sort of grammatical. And then here you'd say there exists x such that phi. So there's no comma here, it just says such that. And, writing things this way, I think it'll always make grammatical sense. But this is actually a terrible way to interpret them. This is a bad way to interpret. Because to really be very, very clear in your head about what these things are saying, you should interpret them in some way without mentioning the quantified variable. So to really interpret them in a way that leads to understanding what they're really saying, you want to interpret them in a way that does not mention the quantified variable, kind of like we were doing here. Everything equals 3 for this one, not for all x equals 3, although they're both correct. Okay, so let's see if we can say what these guys mean without mentioning the quantified variable. So this one, mentioning the quantified variable, the way that always works is to say there exists x such that x equals 3. And then how would you say it without mentioning the quantified variable? Maybe pause the video and think about it. And here's my answer for how to do it. And there's probably many ways to do it, but I would say something equals 3. There's something that equals 3. At least one thing equals 3. So that's what it's saying. And then for this one, the x is bound, but the x is quantified. So I'm gonna introduce the word bound later on. The x is quantified by the existential quantifier, but the y is not. So no matter how I write it, the y's got to get mentioned, but the x doesn't really need to be mentioned. So this says something loves y. And then this one says, well, it says there exists x such that x is green. So it says something is green. And let's do that same exercise we did last time where we replaced the bound variable here, or the quantified variable, by y. Then how does this change? It becomes x loves something. There exists y such that x loves y. So now it's not about y, it's about x. This whole statement is about x. It's saying there's something that x loves. So far I've given you the grammar for these guys, right? Like back here, I gave you the grammar for how to write a well-formed string of symbols using the quantifiers. So that's syntax, and I've given you how to interpret, like how to read it in English, kind of, and what it's intended to mean, what it's trying to say. So that's semantics. So we've talked syntax and semantics, but we have not really looked at the logical rules relating to these things. So how do you prove them? How do you use them? So right now, you have no way of using them in proofs. They're just ways of writing down propositions, and there's nothing really that you can do with them. Unlike these other first 5 guys over here, where you have ways of proving and using them in your arguments. Well, here are the ways of proving and using quantified propositions. So there are these 4 boxes here. And that's what we're going to go over for the rest of the lecture.